Alright, this video is to help determine the molar mass for a substance. The molar mass is the mass of 1 mole of a substance that's expressed in grams. And we already talked about molar mass before. We talked about atomic mass units, and they are going to be the same thing. So remember when you talked about an element's atomic mass, which is that weighted average based upon the isotope abundances? It's also the molar mass is the same value. Alright, now the unit for molar mass is going to be grams per mole, and just remember for the atomic mass, or for the molar mass, they're all found on the periodic table. Alright, there are 3 easy steps we're going to follow in determining the molar mass of a compound. The first one is identify the different types and how many of each element are present. The second rule we are going to do is multiply the numbers of each element in the formula by its atomic mass that's found on the periodic table. And then all we're going to do is just add all of the masses together. Alright, let's take a look at this example, SO3. This formula tells me that there are 1 sulfur and 3 oxygens present. Alright, the first thing you're going to do is just take a look at sulfur and say there are 1 sulfurs, and you're going to multiply it by its atomic mass. And I found this on the periodic table of 32.1. You're going to multiply the 1 times 32.1 together to get 32.1. The next thing you do is you take a look at the next element, oxygen. There are 3 of them present, and you multiply all 3 oxygens by its atomic mass of 16.0, and you get 48.0. Then all we do is add those up. You take 32.1 plus 48.0, and you get 80.1 grams per mole, and this is my molar mass for SO3. Let's take a look at Br2, and this is the formula for bromine liquid, and this formula tells me that there are 2 bromines present. So what we're going to do is we're going to take 2 times bromine's atomic mass from the periodic table, 79.9, and we're going to multiply these together, and we're going to get 159.8, and my unit is going to be grams per mole since we're working with molar mass, and that is my answer. Alright, let's take a look at this one. Now this one might be just a little bit tricky. So let's talk about what these subscripts mean. Now we talked about this once before, but let's do it again. Now the subscripts, whatever is right before, they tell you that they have that many of that atom. So we know right now there are going to be 2 aluminums. Alright, and from here we know that there are going to be 4 oxygens. But then we have this 3 right here to worry about. This 3 is just like in math, it has to distribute itself. So it goes to whatever is right before. But if you have a parenthesis, this 3 will get multiplied by every single thing inside the parentheses. So this 3 gets multiplied to the sulfur, and it also gets multiplied to the oxygen as well. So now we are going to have 2 aluminums, 3 sulfurs, and then 12 oxygens. Everything gets multiplied here, no adding when you distribute. Alright, so we take a look at aluminum. There's 2 of them. Multiply it by its atomic mass from the periodic table, and we get 54. We take oxygen. There are 3 of them here. Multiply it by its atomic mass, which is 32.1, and you get 96.3. Then we take the 12 oxygens, multiply it by 16.0, its atomic mass, and you get 192. And all we have to do is add these up, and we get 342.3 grams per mole. Let's take a look at this one right here. We have 1 sodium, multiply it by its atomic mass from the periodic table. You get 23. We have 1 oxygen, multiply it by 16, and you get 16.0. And we have hydrogen, which is 1 of them, multiply it by 1 from the periodic table, and I get 1. Add those up, and I get 40.0 grams per mole. Now, when you do this, the sig fig rules apply. Okay, so kind of keep that in mind for the sig fig rules. They do apply here. Let's take a look at this next example. Barium nitrate. So same thing, this 3 tells me I have 3 oxygens, but this 2 has to be distributed. So this 2 gets distributed to the N, and it also gets distributed to the oxygen as well, and it multiplies this. Alright, so I have 1 barium times its atomic mass. I have 2 nitrogens times a nitrogen's atomic mass, which is 14. And I also have 6 oxygens from here, because it distributes. 2 times 3 is 6. Times 16, which is oxygen's atomic mass, and I get 96. Add these numbers up, and I get 261.3 grams per mole. Alright, that's it. Hopefully you know how to calculate the molar mass for a substance. If you have any questions, please ask myself or Mr. Kleinschmidt. We'll be happy to assist you.